So hello all data science learners. Today we are again with another video in this series, and today we will be going to cover Naïve bias classification. Naïve bias classification is used for classifying our dataset into various classes for outputs, and it is basically based on Naïve bias theorem, which we have studied in our early classes also. Then it is a very important classifying model. So let's move to the VS Code. So what is Naïve bias classifiers? So Naïve bias classifiers are a collection of classifying algorithm based on Naïve bias theorem. So now you may think, what is Naïve bias theorem? So Naïve bias theorem is used for calculating probability. It is used for calculating probability of A. It is the formula for Naïve bias theorem, that probability of A considering that event B has occurred. Means B has occurred is equal to probability of B such that event A has occurred, and it is into probability of A divided by probability of B. So here we also consider that probability of B does not equal to 0, and probability A and B are some events occurring concurrently. Two considerations are also taken in in this algorithm, that is feature independence. Feature independence means all the independent features which are there in the data set are independent on each other, means all the features on the basis of which we will be classifying the model, so they are independent of each other, and same weight and importance is given to each and every feature. And then now you may think, how does it calculates and predicts the outputs? So Naïve bias basically does that. Suppose we are having the output classes as yes and no, so it will calculate for yes for all the features, like we are having hot weather and humidity, so it will calculate for all hot features and all for all humidity features. Means here it will consider that A will be the yes and B will be hot, so it will calculate first of all its probability, then it will consider that it is yes, then it will calculate for B as a humidity, so it will calculate for all features, and the probability of which it is occurring more, it will be predicting output for that. It will also consider it for yes, no also. The same process will be done for this. So it is a more calculating process, but it is simpler than the other classifies models. So now let's move to the implementation part. So here we are using iris dataset. So here I am splitting the dataset into training data and test data using sklearn.model selection class and importing a train test split function from it. Let's run it. So now I have considered to load the data. So I am loading the data into X and Y features. So let's see into data. So this X features are considering 4 features are there, and the output class. So how many are the output class? So we are having 0, 1 and 2. So total 3 output classes are there. So now let's split this using a train test split. So using the test side as 0.3. Let's run it. So it's splitted. Let's see the extrain data. So this is the extrain data. Here what does mean by feature independence? You can understand that this feature will be independent of this feature. If this feature changes, then this feature is totally independent of this feature. So now using sklearn.Naïve bias, we are importing Gaussian NB class. So Gaussian NB class is a special type of Naïve bias in which we consider that the Gaussian, that the data is splitted, data set is in the form of Gaussian curve, like a bell-like curve. So we are let's run it first of all. Then this is the Gaussian NB model which we are storing in GNB. Then we are fitting this training data then now we are predicting the outputs for X test data so that we can evaluate our model. So here we are again now for evaluating model. In previous video we have understood how to evaluate a model, so here we will consider again how to evaluate a model. So I have importing accuracy score, classifying report, and confusion matrix. Classifying report basically gives all the precision, recall, and F1 score, and many other matrices for classification. So now let's print the confusion matrix. So here we can see this is the confusion matrix. It is of 3x3 size because our output class we are having 3 features, 0, 1 and 2, and then the precision. So precision for 0 is 1, which is quite good, and for 1 also it is 1. And the accuracy, here you can see a second, it is accuracy, so accuracy is also 1, which is a good. So this model is trained very well, and we are implemented it successfully. So I hope you have understood Naïve Bayes theorem. It was based on Naïve Bayes algorithm. The algorithm was based on Naïve Bayes theorem. Naïve Bayes theorem was basically of probability. So we will be calculating probability for all the possible conditions for a specific class, for yes and for no, and then we will be selecting the output which will be having great probability for it. So thank you, and we will meet again in next videos in this series. Thank you and have a nice day.